Hi boys and girls, it's Mrs. J. I know your view looks a little different today. I have some paper set up on a table because there's some math worksheets that I want to work with you on. But I am here, see I'm here. This is actually, I have my phone propped up on a box on top of a dictionary held down with a big heavy paperweight thing of Scotch tape. So hopefully my phone will stay suspended up in the air like this, but this is the best way that I could think of to make like a document camera so we could work on the worksheets together for math. So what you're going to need today, if you can get access to them, if mom and dad can copy them, if not, maybe you can just look at them or you can work with me just using blank paper. But there were two sheets in the framework this week that had to do with fractions on a number line, but they were a little unique because they didn't have regular fractions. They have what we call improper fractions, and that's when the numerator is bigger than the denominator, which is usually a lesson I wait and teach at the end of third grade. But it was in the framework this week, so I thought, well, why not? Let's go ahead and we'll jump into it. And I thought maybe it would be something that we could do together. So if you can get the practice worksheets and the reteach worksheets for 4-3, in the framework, I think they're flip-flopped under the wrong titles. So the comparing fractions are actually the fractions on a number line, and the number line fraction worksheets are the comparing fractions. So mom and dad have to might do a little bit of switching back and forth to see if you can find them. But like I said, if you can't find them, that's okay. You can either just look at them on the screen if you can pull them up, or you can get a blank piece of paper to work with them. Okay, so I'm going to start first with just actually a blank piece of paper. And I want you to think about, let's pretend I had 3 pans of something I baked. Let's make them brownies because I love brownies. Who doesn't love brownies, right? So let's say I had 3 pans of brownies. And let's say I divided those brownies into fourths. Okay, whoops, my third pan's a touch big. So my one piece here, my unit fraction would be 1/4. So if I was to count all the pieces in my first pan, I would have 1/4, 2/4, 3/4, 4/4. But now let's pretend I wanted to count all the fourths together. So let's say I was going to have some friends over and I had 3 pans of brownies and I divided them up, and I wanted to know how many fourths could I pass out to friends and to make sure that I had enough. So if I were to count the fourths, I want you to listen carefully. I would have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4. So I have 12 pieces total of fractions cut into 1/4. Now, if I was to talk about each of these fourth pieces, and I have 12 of them, if I were to count them out or show them or number them in order, I could say that there were 12 fourths. Now, you might also notice that if I divided 12 by 4, what do I get? I get 3. So this is showing me, if you can see this relationship, if I have a whole and I divided it into 4 pieces, I'm going to get 12 pieces total. So the fractions that we're going to be talking about today on a number line, usually we talk about fractions that are just in a one whole so that the numerator is always smaller. But we're going to be talking about, what if we had a second whole or a third whole or a fourth whole of something that we divided up into pieces? How many sections of those fractions would we have? And you can kind of count them up on a number line. So think about that problem. Think about our fourths. And let's look where 7/4 would be. So let's say I counted 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So let's say we were talking about 7 pieces total out of all of our 1/4. So think about that fraction. 7/4. And now we're going to jump to the number line. So this may be a little confusing, but stick with me. If you want to stop and start the video while I work on this, if you want to try and do some of this on your own and then check my answers with yours, you can do that. But I'm just going to kind of plug ahead and go through this worksheet. I know the answer key is provided in the framework, but to kind of make sure you know and understand how you get the fractions that you get on the number line when the numerator is bigger, I just wanted to work through these with you to kind of show you how you would get them. So the first thing that you always want to make sure you look at, you know, we always talk about the denominator. The denominator will always be consistent in telling you how many pieces your whole is cut into. So if I have one whole, I know that I have to have 4/4 if I'm talking about the entire thing. So if I'm counting on my number line, I would have 1/4, 2/4, and I'm kind of just writing over what's already there. And then I would have 4/4. So let's pretend that's our first pan of brownies. But what happens if I have a second pan of brownies and I have a third pan of brownies? Can I count how many pieces I would have that I could pass out? Sure I can. I would just keep going on my number line. So I would have 1/4, 2/4, 3/4, 4/4. Now in my second pan, I would have 5/4, 6/4, 7/4, and if I counted all of that second pan, I would have 8/4. So I would have a whole of something cut into fourths, and if I had 2 pans of them, I would have 8 pieces total. And if you look, 8 divided by 4 is 2. So if I was looking for my 7/4, here is where it would be on the number line. So that's how I would mark 7/4. Let's just go out to our third whole just for fun. All right, so think about our picture when I had the 3 pans of brownies and I cut them each into 4 pieces. And let's figure out how many pieces I would have. So I would have 9/4, 10/4, 11/4, not 12/14, whoops, 12/4. So if I had 3 wholes of something and they were divided into 4 equal pieces, I would have 12 pieces total. So that's how I would get the 7/4. And this shows you if I count on my number line past one entire object, if I had 2 objects or 3 objects cut into pieces, I can figure out and show separate little pieces counted up along the way. So let's look at number 2. We'll do some of these together. So 5/2. So I always want to look at my denominator, and I always know that my whole will be cut into 2 pieces. So my first whole, if I was talking about all the pieces, would be 2/2. And then my halfway mark would be 1/2. I would have 1/2. Now let's pretend I'm going to jump out to my second whole, and I would keep going. So I would have 1/2, 2/2, 3/2, 4/2. Okay, so if you can picture that, so let's say I had 2 objects cut into half. So this is 1/2, 1/2, 1/2, 1/2. But if I counted them all together in order, I would have 1/2, 2/2, 3/2, 4/2. But if you look, 4 divided by 2 is 2, and that's because I would be talking about 2 whole objects. If I was going to count all the way out to my 3, I would then have 5/2, and I would have 6/2, because that would give me 3 objects. And if I drew my third object, 1, 2, 3 objects, and they each had a half, I would have 1/2, 2/2, 3/2, 4/2, 5/2, 6/2, and that would give me my 3 objects total. Okay, so 6/3. I want to look at the denominator. The denominator is a 3. Now I always want to know, I want to go out to the 1, and I know that if my bottom number is a 3, my top number has to be a 3, so that I know I'm talking about all the pieces in my object that's cut up equally. If I were to mark my other unit fractions, or my other fractions in here, I would start with a unit fraction of 1/3, I would have 2/3, and if I kept counting, I would have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, and if I was going to divide this out again, I would have 2 more thirds here that I would have to add. I would have 7/3, 8/3, 9/3. Okay, and I'm looking for 6/3, and this makes sense because 6 divided by 3 is 2. So if I had 2 whole objects and they were each cut into 3 pieces, I would have 6 pieces total. I would have 6 1/3. And out here, like the 3, 9 divided by 3 is 3. So if I had 3 of those objects cut into 3 pieces, I would have 9 pieces total of the 1/3. So that's how you get 9/3. Because we're counting on a number line, but we're representing those fractions in pieces of 1/3. Okay? Let's jump down to 8/5. So I would want to know where to find 1. And I know that I would have to count to 5/5 to get 1 whole. So I have 1/5, 2/5, 3/5, 4/5, and then I have 5/5, which would give me 1 whole. But I have to keep going because I actually need 8/5. So 1, 2, 3, 4, 5, 6/5, 7/5, 8/5, and I kept going. I would have 9/5, and if I got to 10/5, 10 divided by 5 is 2. That would be my second whole. Okay, my second whole object. But there's my fraction 8/5 that I would be looking for. Okay. Now this one, they're just giving us the whole number 1, and my denominator is 4. So if I have 4 pieces, I have to be talking about all 4 of them together to equal 1. So I want to find the fraction 4/4. So I have 3/4. I know 4/4 would be labeled over here. I would come this way to do 2/4, and I would have 1/4. So 1/4, 2/4, 3/4, 4/4, and that would equal 1. Okay, and that's my 1 there. So if you had the reteach worksheet, that's what that would look like. You can always do these on a separate piece of paper. You know, just draw a line, put the arrows at the end, and make sure you always start at 0. And you can just count along and do the separate little fractions like I did along the way, and just count along on a number line. Make sure you have the denominator right, because that tells us how many each of these whole objects is cut into. And you just count along until you find that fraction. You just have to go past the whole number 1. So let's look at the practice worksheet. Up at the top, 1 and 2, I'm going to skip because these are just regular fractions. This is for review. So here's your one whole number out here, and you just have a regular fraction of 1/8 to find and 1/5 to find. So you would divide this line up into 8ths, number them all out, find the 1/8. You would divide this line into 5ths and find 1/5. Now number 3 is a little unique in that they've given us 2 different fractions with 2 different denominators, and they want us to mark it on the same line. We have to find 1/3 and 5/6. So I know my number 1 out here. Let's start with 1/3. So if I'm going to start with my 1, I know that I have to have 3/3 be my ending fraction here. And that also means that I have to have my fractions on a number line divided into thirds. So I'm going to make a line here, and I'm going to make a line here so that I have thirds. And I'm going to mark 1/3, 2/3, and then this would be 3/3 would be my whole. Now I'm going to use a different colored marker for sixths since they want us to use it on the same line. So now this time the denominator for my second fraction is 6. So I know that if I want to find 1 whole, my final fraction will be 6, 6, because I have to talk about all the pieces in the entire object all together to have the whole thing filled in. So now my fraction pieces that are cut in third, I'm going to double divide them so that now I have 6 pieces. 1, 2, 3, 4, 5, 6. And I can mark out 1/6. Oh, look at that. They are on the same spot on the number line. 1/6, 2/6, 3/6, 4/6, 5/6, and then 6/6 would also be 1 down here at the end. So they want us to mark 1/3. There's 1/3. They also want us to mark 5/6. So that's how you would find 2 different fractions on the same number line when the denominators are different. Sometimes it's easier if you use different colors like I have, if you've got different markers or different colored pencils or a highlighter even. And I like to do the fraction with the bigger numbers first, because then usually if you do the smaller ones in between, it's kind of easier to count. But you'll see sometimes fractions on a number line end up on the same spot because they take up the same amount of space. We talked about this when we started our measuring unit, when we talked about fractions. We talked about 2/4 being the same as 1/2. And that's why on a ruler, just to make it simpler, they always have 1/2 instead of 2/4. So that's how we got our half in the middle of our 1/4 and 3/4 on our number line. So let's go down and practice the problems at the bottom. 4, 5, and 6. Now for number 4, I'm going to switch back to my black marker. For number 4, we're going to start by looking at the denominator, and if I'm looking at what the first whole would be, if my denominator is 2, I know my denominator is 2, my numerator has to be a 2. So if I'm counting on my number line, I would have 0 blank 2. Well, that means right here I would put a 1 and make that 1/2. And then I could keep counting. So I would have 0, 1, 2, 3/2, and then my other whole number, I would have 4/2. Now let's see if that makes sense. 4 divided by 2 is 2, so that would give me 2/2. This is the same picture if I had 2 whole objects and they were divided into 2 pieces, and I was talking about 1, 2, 3. 3 of the halves. That would be this point on the number line. All right. Now, 5 and 6 are a little tricky. Number 5 is 9/3. And we're going to start, first of all, talking about just the whole numbers. Because 9 divided by 3 is 3. And you know that that's how we always find the spot on the number line that's whole numbers. Now, the way that this would be divided up is that each of these pieces would be divided up into thirds. So I would have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3. Okay, because that's how many ninths I would have if I had 3 objects and they were cut into 3 pieces each. If I went to 8/4, you might be able to recognize right away that that's a whole number of 2. So I would have 8/4 out here, because that would equal 2, and my 1 would have to be 4/4. So I would have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. And I kept going. If I kept going, this would be just like our brownie pan picture that we started with at the beginning. We'd have 9/4, 10/4, 11/4, 12/4, because 12 divided by 4 is 3. Now, I'm going to see if you can do this problem down here independently. We've done this together. See if you can pick one of those problems and maybe retell in your own mind or in your own words. If you had to explain to somebody else how to find a fraction like this on a number line when the numerator is bigger than the denominator, see if you can do it. So this was a little tricky today, so I'm glad we got to spend some time together doing it. I hoped it helped. If you didn't have the worksheets like right now, I said that's okay. You can come back to them later. You could have just watched the video and looked and listened and learned. That's okay. If you had scrap paper, you could have done the problems on scrap paper also. But since they were in the framework this week, I just wanted to give you a little bit of a lesson on how to do those so you had a better understanding of how to find fractions on a number line that are greater than 1. So thanks for joining me, and I hope you had a great day, and I'll see you soon. Bye.